Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Order of Operations, Evaluating Expressions. All right off the bat, let me tell you, this is not going to be treated like a brand new lesson like the other ones will be later this school year, because this is basically a review of things you've already learned in 6th grade math. So we're going to treat it that way. So let's start off with an important vocabulary word, the word evaluate. To evaluate a mathematical expression means to find the answer or value of that expression. Now, the way that you do that is by following what is called the order of operations. You've probably heard of order of operations referred to as Please Excuse My Dear Aunt Sally, or possibly the acronym PEMDAS, where each letter or set of letters represents a specific step. Let's talk about them real quick. We all know P is for parentheses. This also includes brackets, math problems and fractions, which I'll talk about a little bit later here. E is for exponents. Now, multiplication and division are actually considered both the third step. You will not always multiply before you divide. You will do that step going left to right. So whoever is further to the left is what you would do first for step 3 for the multiplication and the division. And then finally, we have addition and subtraction. Again, those two operations are considered one step, the final step to order of operations. And just like you would do with multiplication and division, you're going to add and subtract going left to right, which means you will not always add before you subtract, which is a common mistake from students in 6th grade math. All right, let's look at an example. This is already typed up for you. You can see I found the parentheses. I did that first. Then I did the exponents for the second. Then I multiplied and divided going left to right with that section there. Finally, I added and subtracted, but going left to right like it says. And notice I am working down step by step. This is very important. Working down, good. Not working down where you would put an equal sign and then do some more work, and then put another equal sign and do some more work, and then put another equal sign and do more work, and then run out of room, and then have to go to the next line of your paper from another equal sign. Ladies and gentlemen, that is horrible. Don't do your work that way. Work down. It's so much easier to follow. I can tell you where this 3 came from. It came from the stuff that was right above it. Easy to follow math work. That's what we want you to do, and that's probably how you were trained back in 6th grade math. All right, so let's go ahead and take a look. Before we do some problems, let's quickly talk about multiplication. Many different ways that it can be shown. It can be shown with a times dot. That's the most common way, not the same as a decimal point, a little bit higher up. Sometimes you're going to see numbers next to parentheses with nothing in between. That also means multiplication. You're just not going to see the x used anymore for multiplication because x is the most common variable, which is a letter that stands for a number, often unknown. So we're not going to use x for multiplication in our math expressions. Also, if you ever have a number multiplied to a variable, which we'll get to on problem number 4, you won't even see a times dot in between. You'll just see the number next to the variable with nothing in between. That's the most common way of showing a number times a variable. Okay, get your pencils ready. We are finally going to do the first problem of this guided notes that's not already done for us. Problem number 1. Now, I'm going to lead you through numbers 1, 2, 3, and 4, and then you'll do the back side of the guided notes, numbers 5 through 11, on your own. So do not work ahead. Make sure you're staying with me. Make sure you're writing things down the same way you see me doing it here on your screen. That's very important when problems are modeled for you by your math teacher. Okay, so problem number 1, order of operations. Do we see any parentheses? Not on problem number 1. No, we do not. What's next? Exponents. Do we have exponents? Yes, we do, right here. So 9 to the second power is going to give us 81. Why? Because 9 to the second does not mean 9 times 2. Nope, it means 9 times 9, which is 81. Now, we're going to bring everything else down. The minus, the 17 times 2, the plus, the 108 divided by 9. All of that gets brought down. I know some of you probably don't want to do it that way. You instead want to put the 81 like above or something weird like that. I'm telling you, keeping your work organized by working down, like it said right here, is going to be the best way to make you successful on not just the problems of these guided notes, but also other guided notes throughout this year. Okay, what's next with the order of operations? It's multiplication and division. I will allow you, since the multiplication is here and the division is here, notice there's a plus in between. I will allow you to do the multiplication and division at the same time because if you recall, multiplication and division are both the third step. Now, if they were right next to each other, like in the problem above, then you're going to have to do one part and then later do the division. But when they are separated by something else in between that will get done later, such as addition or subtraction, then yes, you may multiply and divide at the same time. So here we go. 17 times 2. Maybe you don't know what 17 times 2 is. If not, go off to the side and do the type of work you did in elementary school. 7 times 2 is 14. Carry the 1. 2 times 1 is 2. Plus 1 is 3. After you get that result, you're going to go ahead and bring it straight down underneath the 17 times 2. Now, I went ahead and did for you, because I'm a nice guy, 108 divided by 9 is 12. Maybe you know your 9 times tables up to 108. 9 times 12 is 108. So we're going to bring down the plus. We're going to bring down the minus that we haven't used yet, and the 81. All of those parts get brought down. Now, you'll see I drew these diagonal lines to show you where the 34 and 12 came from. It's not required that you draw those lines. Some kids like to do it. Other kids don't really want to. Fine by me either way. Just make sure you're bringing down all the rest of the numbers and math symbols that we have not used yet. Okay, should I now do 34 plus 12? Please excuse my dear Aunt Sally. Well, no. Remember, with addition and subtraction, you are going to do that step by going left to right, which actually is what we had to do with multiplication and division on this earlier problem that we were looking at. So, addition and subtraction going left to right. Notice the subtraction is further to the left than the addition. So, let's do 81 minus 34. Now, if you don't know what that is, maybe you can't do that in your head. Again, you'll go somewhere off to the side, and you don't have to label it side work like I did here on my screen, but go somewhere off to the side. Maybe you have more room to the left. Maybe you have a little room to the right to do it. I'm not quite sure. You have to make that judgment on your own. Let's go ahead and do some borrowing because 1 is smaller than 4. So we're going to borrow from the 8, making that a 7, and then that 1 becomes 11. Subtract 11 minus 4 is 7. 7 minus 3 is 4. I hope you're writing all this down with me, unless you were able to do 81 minus 34 in your head. You notice we're not using calculators as we do these guided notes. No calculators. So that gave me 47. I'm going to bring down the 12 and the plus. Finally, 47 plus 12. 2 plus 7 is 9. 1 plus 4 is 5. And boom, there you go. 59 is our answer. I like to put, instead of an equal sign, because these were not equations. They did not have equal signs. Instead, I like to circle the final answer, and most of you will probably do that whenever you get final answers on problems throughout this year. All right, let's do a problem a little bit more interesting than problem number 1. Problem number 2. What makes this interesting? Well, we have parentheses. And a lot of kids are like, Mr. Underkoffler, what do you do if there's more than one thing inside of your parentheses? Well, you're going to follow PEMDAS even inside of parentheses. So in these parentheses, you're like, what's first? Well, multiplication would get done before subtraction, according to PEMDAS, according to order of operations. So let's do that first. 6 times 2 is 12. Now, everything else gets brought down. The parenthesis and the exponent of 3 that was on the outside, the 22 and the minus, the parenthesis that was to the left of that, and then everything else. Now, you'll notice that over here on the right in this little box, I had mentioned that parentheses do not disappear until every math problem inside has been finished. Well, we still got another math problem to do. 22 minus 12. So that's why the parentheses are still there. I still need to do 22 minus 12. That's going to give me 10. Now that I have done everything in parentheses, I don't need to write them anymore. And that little exponent of 3, boom, gets brought down. No more parenthesis is needed. But you might be like, Mr. Underkoffler, what is that 5 doing to those parentheses that we used to have? Well, it's actually being multiplied. When you see a number next to parentheses with nothing in between, in fact, this was mentioned above this section of problems in the middle of your notes, that means multiplication. So go ahead and put 5 times dot, and then the result will be got the 10 and the exponent of 3. Oh, and don't forget the 19, that's still there, and the plus. If some of you wanted to do 19 plus 5 early and got 24, that would actually have been wrong. And you're about to see why. The addition will be done last according to order of operations. Okay, 10 to the third power. 10 times 10 is 100, times another 10 is 1,000. In fact, there's a cool little trick about exponents with tens. The exponent is the number of zeros that you end up having for that answer. So that's kind of a cool little trick. I don't know if you ever were taught that before with exponents of tens. Okay, so bring everything else down. Now, do I add yet? Nope. Got to do order of operations, multiply before you add. That's going to give you 5,000. Bring down the 19, and then finally I get to add 5,019. All right, problem number 3. Oh, we got this fraction. What in the world is this? Well, check it out. I have this explained over on the side. Math problems in fractions are actually part of the parentheses step. You might be like, well, Mr. Underkoffler, I don't see any parentheses there. I know you don't see them, but these are actually considered to be in parentheses whenever it is inside a fraction. Well, we also have a math problem down here in this part of the fraction, the denominator of the fraction. So that is also considered to be in parentheses. So this problem is unique. We actually have 3 separate sections that are parentheses. We have the 7 to the second. That was clearly in parentheses. We have the 16 plus 4 times 21. That's in parentheses. And we have 5 to the second. 3 separate sections of parentheses. I will allow you to start each of those 3 sections at the same time. So let's start with 7 to the second. 7 to the second is 7 times 7, which is 49. Since the 2 was on the outside of the parentheses, that means 2 times 49. All right, let's go ahead and bring down that minus as well. Let's start the numerator, because that part was in parentheses, even though we didn't see them. Math problems and fractions are part of parentheses. Should I add or should I multiply? Well, you gotta follow PEMDAS inside of parentheses. So we're gonna multiply. 4 times 21 is 84. Bring down the 16 and bring down the plus. Bring down this fraction bar. Start the bottom part. 5 to the second is 5 times 5. That is 25. All right, hopefully you've written this down the same way you've seen me do it as well. Okay, we still have more to do in the parentheses of the numerator and of, oh, actually that's it. The denominator's done. The 7 to the second, that was the only thing in the parentheses for that part. But I still need to do this parentheses sections right here, 16 plus 84. If you need to go off to the side and figure that out, you may. I'm going to go ahead and tell you what that is. That's 100. We still have it over 25, so don't lose that. And we still got 2 times 49. You might be like, well, could I do 2 times 49? Not yet. That part is not in parentheses. The 16 plus 84 was considered in parentheses because it was a math problem in a fraction. Speaking of math problems in fractions, there are no more math problems in fractions. So that part, the parentheses are done. Are there any exponents? No, we already dealt with that from inside of the parentheses. Is there any multiplication or division? Yes, we have multiplication here. We have division here with the 100 and the 25. That fraction bar means division. So let's go ahead and do this. 2 times 49. If you don't know what that is, you can go off to the side. 9 times 2 is 18. Carry the 1. 2 times 4 is 8. Plus 1 is 9. And boom. we get 98. All right, let's go ahead and write that down. Bring down the minus. 100 divided by 25. I hope you know your trick of 25s. They're like quarters. So you can ask yourself how many quarters make $1. That would be 4. And now we just have to do 98 minus 4 to finish up the problem, and that is 94. If you need to hit pause to catch up on writing any of this down, please know with videos you're allowed to hit pause at any moment that you need to. You're allowed to rewind things if you need to hear things said again, or if you need to quickly see something again. So please use those features on this video. Just don't be fast forwarding and missing stuff or doing 1.5 speed. That would not be good either. All right, one more problem I want to do with you. And I know some of you are already ready to want to do things on your own. I know, but this is a little bit different. I want to do this one with you. This is a problem that says to evaluate the expression, which means find the math answer, but it tells you values of the variables. And you're going to see here we have some variables. We see that x is supposed to be 12, so we are going to replace the x with the 12. And we see that y is 5, so we're going to have to replace these y's. So before we do any multiplication or addition or subtraction or exponents or anything like that, we're going to do a step called substitution, where we rewrite the math problem, but instead of having letters called variables, we replace those variables with the numbers that they equal. So instead of 3 times y to the second, it's 3 times 5 to the second. And if you forgot that a number next to a variable with nothing in between means times, well, then let me be the person to remind you that's what that means. Likewise, this is 2xy. That really means 2 times x times y. So that's 2 times 12. I got that from the directions. X is equal to 12 times, we know y is 5. So yes, even when you have a letter next to another letter, meaning a variable next to another variable, with nothing in between, that means times. Okay, order of operations. Before I do the multiplications, I need to do the exponents. 5 to the second, we had that on an earlier problem. That's 5 times 5, that's 25. Bring everything else down. So bring down the 3 times, bring down the plus, bring down the 2 times 12 times 5. Now, I kind of did a little cheating here, not really cheating, but I started doing 2 times 12. Technically, I shouldn't have done that yet. I should have done the exponent first, but since there is addition in between, and I know that's going to be done later, I can kind of do the 2 times 12 a little bit earlier than you technically should, and I'll be safe. It will be okay. Okay. Let's finish the 2 separate sections of multiplication. We have multiplication here, we have multiplication here, and again, I said this addition's in between. We know that's going to be done last. 3 times 25, do you know your quarters? 3 quarters is 75 cents. 24 times 5, if you don't know what that is, go off to the side. 4 times 5 is 20, carry the 2. 5 times 2 is 10, plus 2 is 12. So we got 120. We're going to write that down. And then 75 plus 120 is 195. Okay. Turn to the back. And ladies and gentlemen, it is now finally the time for you to try some problems on your own. And I want you to do all the remaining problems on your own. I already did number 5 for you. Just a reminder, when you have variables, the first step should not be actually doing the order of operations yet, but instead what we call substituting, where you rewrite the entire math problem, but with the letters replaced with the numbers that they equal. And again, those letters are officially called variables. Then you do order of operations from there. So what I want you to do is hit pause on this video and do 6, 7, 8, 9, 10, and 11 on your own, and then hit play once you are ready to see if you got them right. Okay, have you already hit pause on the video and have done the rest of the problems on your own? If not, you better do that now. Okay, problem number 6. Did you make your rewriting of the problem, substitution step, look exactly like this? From here, did you do multiplication? 3 times 4, 5 times 12 gives you 12 and 60. Did you subtract before you added? This was mentioned on the first page. Addition and subtraction. You can read it. You can go back to the first page and look at it on your own. Step 4. You do addition and subtraction going left to right, meaning if the subtraction is further to the left than the addition, then you would subtract before you add. If you mess that up, hit pause on the video, fix it on your paper, and then hit play when you're ready to move on to number 7. Here's problem number 7. Does your substitution step look exactly like this? Did you start with the parentheses and follow order of operations in the parentheses? 6 times 4 is 24, and then 12 plus 24 is 36. Now you need to bring down the rest of the problem with it. 14 times 5, you could go off to the side and figure that out. That would have given you 70. And by the way, if you got the 70 a step earlier than I did, that's fine. Even 2 steps earlier would have been fine because the minus we know would be saved for last according to order of operations. So yes, you could have multiplied 14 times 5 earlier than I did. 70 minus 36, maybe you don't know what that is off the top of your head, so go off to the side, do some borrowing, you get 34, and that is your final answer. Moving on, number 8, we substitute. Number 9, we substitute. Are these problems going to be the same? The answer is no. Number 9 has parentheses with the exponent on the outside. So what's inside gets done first. Well, that's not how number 8 would be started. Number 8, the 5 and the 4, they are not in parentheses. There's no parentheses at all. So on number 8, you need to do 4 to the second first order of operations. Do exponents before you multiply, unless the multiplication is in parentheses, like we had in number 9. All right, let's finish off number 8. What is 5 times 16? If you don't know, you go off to the side, and boom, 80. Problem number 9, 20 times 20 is not 40, it's 400. Just like 10 times 10 is 100, 20 times 20 is 400. Go ahead and fix it if you need to. And finally, problem number 10. Did your substitution step look like this? Did you realize there are 2 sections of parentheses? The numerator is considered to be in parentheses, and the denominator is considered to be in parentheses. So start the numerator, 4 to the second, should be done before you multiply by 3. The exponent is before multiplication. 17 minus 5, that's what I meant to say, gives you 12. Bring everything else down. 11 times 5 is not in parentheses. 3 times 16, if you don't know what that is, go off to the side. You're going to get 48, still over 12. Now, if you did 11 times 5 and got 55 a step earlier than me, that's fine, because we know addition, which is in between, would be saved for last. Speaking of multiplication and division, you can do 48 divided by 12 and get 4. Finally add 59. If you need to hit pause and fix your work, please feel free to do so. Or feel free to do so, that's what I meant to say. If you need to rewind the video at any point, you may do that as well. But other than that, that's all I have for you on this video. Thank you for watching. We'll see you next time.